Hello friends! As I briefly mentioned in my last video, a couple of really large packages have arrived here over the course of the last week. These packages were sent here from Zurich, Switzerland. And to get you in the right mood for the kind of stuff that you're about to see, let me show you some historic footage first. This is some original footage from the Atoms for Peace Conference 1958 in Geneva, Switzerland. And now listen to the record of an original TV report of the time.
Am schweizerischen Stand begrüßt Professor Scherer Herrn Hammarskjöld und seine Begleiter und schildert Ihnen die raschen Fortschritte der schweizerischen Atomforschung. Was Professor Scherer seinen Gästen hier nicht zeigen kann, ist die schweizerische Abteilung in der industriellen Atomausstellung im Genfer Palais des Expositions, wo schweizerische Präzisionsgeräte für die Atomindustrie einen bedeutenden Platz einnehmen. Unsere Fabriken haben den Anschluss auf diesem Gebiet erfreulich rasch gefunden.
And this is a picture of the EIR, or Paul Scherrer Institute as it's known today, the Swiss Nuclear Energy Research Laboratory. And here you can see footage of the installation of the experimental heavy water research reactor at Würenlingen. And why am I showing you this? Well, this is where these packages came from. And later in this video, when you have seen what's inside the packages, this equipment right here might seem a little more familiar to you. So it's an oscilloscope obviously, but not just any oscilloscope. This is a Tektronix 551 vacuum tube dual beam oscilloscope manufactured by the American manufacturer Tektronix obviously in Portland, Oregon, and that would have been between 1958 and the middle of the 1960s. So let's just open this up and take a look at some of the details inside, and after that we can then also perform a rudimentary test of the most basic features of the oscilloscope and see if they're still in working order. Let's first take a look at this bank of vacuum tubes here, and we can see that some of them are from different manufacturers. Now this one was manufactured by General Electrics and it has a stamp on here saying 6204, and I interpret that as 4th week 1962. Now see, this one here was manufactured by RCA, Radio Corporation of America, and it says 6139, so 39th week 1961. But we also have German vacuum tubes in here, like this Telefunken tube, and I would guess that the German parts that we find here are actually replacement parts that were put into the device by the technicians working in Switzerland. While I guess that some of the American tubes could at least be still the originals that were inserted into these sockets back in Portland, Oregon when this was manufactured. So I guess that this unit was maybe made in 1962, but I could be wrong about this, could be as early as 1958. And here you can see the typical construction style that was used in these oscilloscopes. It was, of course, before printed circuit boards were common, and you can see that they have used some kind of soldering strips, and I guess these are made of some type of white plastic. Here you have a bunch of trimmer potentiometers for the different screen adjustments, and here you can see an old-fashioned rotary switch that is typical for measuring equipment of this era. And here under this aluminium sheet cover we find the high voltage power supply of the oscilloscope, which back in the day would have been called EHTs for extra high tension power supplies, I guess. And as the cover tells us, it's actually less dangerous than the medium voltage circuits inside the oscilloscope, and that is because of the high internal resistance of the power supply. That means that it cannot deliver high currents, which is what kills you at the end of the day. And at first glance, I would say that this is some kind of flyback converter, so this is a switch mode power supply, even though a very ancient one. And here you can see the secondary side rectifiers of this flyback converter, and where you would expect semiconductor diodes, back in the day they used vacuum tube diodes. And here we have a data sheet for these exact parts, and you can see that it says here that they were made for EHT power supplies. And here we have something that you really don't see every day. It's a whole range of small inductors that are stacked on top of each other. They appear to sit on a common core, and this assembly really goes through the entire device. And when you look inside these little holes, you can see that there are a lot of small adjustable capacitors sitting in there. And what this is an LC delay line. You know, the L for the inductors and the C for these capacitors here. And here you can see what that looks like in the schematic of the oscilloscope. So let's turn the oscilloscope around. And here you can see that there is a second LC network on the other side. And that is, of course, this is a dual beam oscilloscope, and there are actually a lot of things in here, not one, but actually two times. And here we have what looks like a large line frequency transformer, and you can see that the windings of the transformer do not lie open, but are covered. And those covers, those shields, are not just made from sheets. They appear to be made from some kind of cast aluminum alloy that was then also coated. So this is really a very high quality production style that you don't see anywhere today. And of course, this device dissipates a lot of heat, and that is why you absolutely need a fan inside the enclosure. And what we have here is an induction motor with aluminium blades. And well, today we use brushless DC motors for these kinds of purposes, but you can see that an induction motor serving as a fan can hold up for over 50 years and can be still alive and kicking. And another great lesson here, if you use a fan, also use a filter, and then you will not have a lot of dust inside your devices at all. And let's have a look at the bottom of the device, and here you can see more of the same construction style that we saw before. The parts on the right side here are plug-in units that are actually attachable and detachable from the device itself. And you can see here that you can just screw them off and pull them out. And this kind of modularized design would have been quite modern at that time. And if you take a closer look at the front panel, you can see two more things. For one, we have UHF connectors on the device, and then UHF to BNC adapters screwed on top of them. Which, as I read on the internet, means that this is one of the older units. And if you take a closer look at the plug-in units, you can see that they are a little different. The right one already has a BNC connector, while the left one still uses UHF. And you can also see that the oscilloscope was made in Portland, Oregon, and one of the units was also made in Oregon, but the other one was actually manufactured in Guernsey, which is, as far as I understand it, a crown dependency of Her Majesty the Queen of England. And that's of course where my greetings go today, to Portland, Oregon, and to the island of Guernsey. And if you come from one of those places, please leave a comment in the comment section, and especially if you're coming from the island of Guernsey. I mean, there must be at least one viewer, right? But before we test the unit, let's take a brief look inside the power supply as well. And what you can see here is, of course, pretty much the same construction style. We see more of the mains transformers, the type of which we have seen in the oscilloscope. But then we also have these rather large German-made vacuum tubes in here. And if we check the data sheet for this particular type of vacuum tube, we can see that it is designed for linear regulators. And this is quite interesting, because if you think about it, before they had transistors, they also would have had the necessity to stabilize voltages at certain output currents. and just a stabilizer tube wouldn't have been enough for that. So they actually made linear voltage regulators with vacuum tubes, in this case double triodes instead of transistors. So last but not least, I will connect my self-made sine wave generator to this antique behemoth of electrical engineering, this shining example for what American engineering can do if it wants. And let's just take a look at it, shall we?